send me pictures of them. They're pretty cool. Am I keeping you up there? All right. Yeah, gotta get that requisite amount of sleep. Okay, so, what we wanna do is we wanna go over the quiz from yesterday. And the first part of the quiz involves seeing if something is a solution, and we talked yesterday about how there's all these numbers floating out there in Numberland. And when we solve an equation, we come up with a potential answer, and we're supposed to check it to see if it's actually true. Now, if you checked every equation, it would drive you nuts. I know Mr. Frank really likes to check equations, so I'm sure he taught you really, really well how to check equations. So we do it sometimes, but we don't do it nearly as frequently as you did it last year. In this question, I give you an equation that looks pretty complicated. It says 6x plus 5 equals 5x plus 8 plus 2x. And, oh, I know why this is doing it, because of the display on my calculator, on my computer. Okay, that makes sense. It says, is x equals -3 an answer to this? So every single place that I see an x, I'm gonna put a -3. So 6 times -3 plus 5 equals 5 times -3 plus 8 plus 2 times -3. And now I just go through and I do the arithmetic and see what I come up with. 6 times -3 is -18 plus 5 equals 5 times -3 is -15 plus 8, and then 2 times -3 is -6. -18 plus 5 is -13, and -15 plus 8 is -7, and -6 is -13. So the answer is yes, because they checked. Now, there were a number of people who wrote no, but they did try to check the right way. So you only lost 5 points if you did that. If you tried to solve the equation and come up with the solution, you lost a lot of points, because the intent behind this question is to get you to see, to check it, to see if it comes out to be the check. Any question on that? All right, now number 2, I noticed a mistake that was pretty common among a lot of people. And let's hope that tomorrow, that mistake is not happening. Now, the really good news on number 2 is just about everybody realized that this was a same side, same operation situation. So I saw everybody say 3n plus n is 5n. And then I saw everybody try to get the -4 and the +5 together, which is really good, and that's exactly what you should do. But this 4 is negative and this 5 is positive. +4 and +5 add up to +9. Take a look at your paper. Did you put +9 down there? Did you write 5n plus 9, or even 5n minus 9? These have opposite signs. Because they have opposite signs, you should be saying, oh, I'm gonna end up subtracting and keeping the sign of the bigger number. Remember, 4 negatives looks like this, 5 positives looks like this. These and these take each other away. The only thing left is a +1. Is 26 minus 1, 5n is 25, divided by 5, n is 5. So once again, we saw a common mistake with the -4 and the 5. Your heart is in the right place. Your strategy is correct. You're trying to combine the like terms, same side, same operation. The mistake you're making is you got to pay real attention. You look in front all the time. What kind of 4 is this? And what kind of 5 is this? So when the signs are opposite, you end up subtracting and keeping the sign of the bigger number. All right, number 3. 4x minus 1 is equal to x plus 20. As generally, we did a really good job on this. Shorts, I think you got this one wrong. Didn't you get this one wrong?
Number 3,
Yeah.
I think. Yeah.
Yeah, I was wondering where it went. I mean, I think if I remember right, you did the minus x on your paper. And we got 3x minus 1 is 20. And then, like, you kind of ignored the -1. Is this ringing a bell?
Yeah.
Yeah, I mean, before you can solve this, this is your standard 2-stepper. You got to add the 1.
Well, I
So-
didn't even get 3x.
What was that? What did you get? Don't tell me 5x.
No. I tried to cancel out the 4 and then add 4 to.
Yeah, there were a few people, I don't know if this was you or not, but there were, I'd say 2 or 3 people who sometimes tried to mix the numbers with the x's. You've gotta keep your x's with your x's, and then a little later, your numbers with your numbers. You can't say 4x minus 1 is 3x, or x plus 20 is like either minus x and get 19x. You can't do that. Numbers go with numbers, variables with variables of the same type. If you will, you put like things together or things after their own kind. You can't mix numbers and letters. It's like this. Shorts, what's 2 puppy dogs plus 3 puppy dogs? No, it's not 5.
Puppy.
5 puppy dogs. What's 2 fishing rods plus 3 fishing rods? Or in your case, what's 2 pairs of shorts and 3 pairs of shorts?
5 shorts.
Good. What's 2 puppy dogs and 3 pairs of shorts? It is what it is. It's 2 puppy dogs and 3 pairs of shorts, right? Well, this x is as different from this 1, and this x is as different from this 20 as puppy dogs are different from shorts. Now, when I get all of my x's together, it's like getting all my puppy dogs together. And when I get all my numbers together, it's like getting all my shorts together. Now I can divide. X is 7. Okay? So be wary of that.
Oh, I got that the first time, but I got
Yeah, you should have gone with that. All right, that would have been a whole lot better thing. You know what surprised me about that is I think personally that you're as bright as any kid in the room. And I'm looking at this going, where is he coming up with this from? You know, I mean, is he like getting creative here? I mean, what's happening? I don't understand. All right, next one up. 2 times x plus 4 plus 3x minus 9 is equal to 19. Now, before I begin this, what do I have to do as my very first step? Michael? Very good. Distribute. What does distribute mean in the English language, everybody? To give out. Very good. In the context of a math problem, though, it means specifically to give it out to whatever's inside of those packages. So 2 times x is 2x, 2 times 4 is 8, plus 3x minus 9 is equal to 19. Now, I want to get all my x's together, just like I want to get all my shorts together. This is peeking in front, 2 x's and positive 3. What's 2 x's plus 3 x's? Everybody? 5 x's. Patrick, I know you got 100 on this, buddy, but try to keep yourself sharp here, okay? Now, what kind of 8 is this? Positive. What kind of 9 is this? When I add them, do I get 17? No. What do I get? What am I going to get, Lizzie? Negative. It's going to be negative because the longer list, if you will, the sign of the bigger number is the negative. The 9 is negative. Equals 19, and then I'm going to add 1 to both sides. 5x is 20, dividing by 5, x is 4. Okay? Any question on that, guys? All right. So, look, we certainly didn't do badly on the quiz, but we could do just a little bit better. I know Leah got a nice grade, but don't you want the 100? Right? That's how it should be. Yarlene, another nice grade. Get that 100. We got Lucero got 100. Patrick got 100. Patrick's like the quiet assassin in the room. Like, you never hear a word from Patrick, and all of a sudden it's like, yeah, I got 100. All right. Eric, did you get 100? Eric got 100. 1, 2, Michael, and Cheyenne she got 100 yesterday. She's not here. Hopefully we can get a whole lot more hundreds tomorrow. All right, so let's talk now about today's lesson sheet. And we'll start with the do it. Evaluate 4 to the negative 2. That's okay. Evaluate 4 to the negative. You do know I'm going to go back and forth, of course, there like 30 times during the rest of the class, right? Okay. Negative exponent. So that's 1 over 4 to the positive 2. What is 4 to the positive 2? 16. So that's 1 over 16 plus, what is anything except 0 to the 0 power? 1. So 1/16 plus 1 is 1 and 1/16. Okay? Number 2, which choice best describes the number of solutions to that equation? Now, if I distribute here, I'm going to get 5x minus 15 equals, now I'm going to do same side here, what's 2x's plus 3x's? 5x's minus 15. I get a little methodical here, I subtract 5x from both sides.
and I get negative 15 equals negative 15. Okay, great, it does. How does that impact the number of solutions? Is it choice A, x is 25? Is it choice B, there is no solution, or C, there are an infinite number of solutions? Patrick? C, yeah. It means any number that you plug in will work because it'll always simplify to negative 15 equals negative 15. Okay, Tommy is not sure how many dollars is in his bank account. He asks the grand, oh, what the heck is that? That must be like spell check automatically changing it. I'm not that dumb. He asks the Grand Deacon of Dinero, isn't that a great name? I made that up. Did you get it? Right? It's about money. You know what dinero is in Spanish, right? Money, the Grand Deacon of Dinero. That's a great name. One day Lizzie will be the Grand Deaconess of Dinero. That means you'll have big bucks. And he asks him, he asks the Grand Deacon of Dinero to tell him, and the Grand Deacon says, I will give you a hint. If you double the number of dollars and then add 75 to it, the result is the same as if you multiply the number of dollars by 5 and then subtracted 12 from it. How much money does Tommy have in his bank account? Okay, so now what we're going to do is work this question out. And this is a significantly more difficult word problem than any of the ones that we did yesterday. But it's not so bad. Now, yesterday, we said that every time you do a word problem, we read it once, which we just did, and then we go back through that word problem and we pick up the important things, we write them down, and then we cross out what we've used up. So, Tommy's not sure how many dollars is in his bank account. Great, that doesn't sound too important. He asked the Grand Deacon of Dinero, and the deacon says, I'll give you a hint. None of that's important in terms of the equation yet. If you double the number of dollars and then add 75 to it, now we're talking, that's got some importance. How would you write double the number of dollars and add 75? How would you do that? Eric?
2n plus 75.
Okay, good. 2n plus 75. So now I'm gonna cross this out because I used it. As soon as I use something, I love to put a line through it. Because you know what happens? Especially with the Common Core. Last year was a really unique year where kids were allowed to take 2 Regents exams for algebra. They took a Common Core Regents exam on June 3rd. And then sometime around June 20th, they took the integrated algebra test. So I had this one girl who was on home teaching. Her name was Brittany. And Brittany's a pretty good math student, and she was on home teaching for much of the year. So when it came to practicing for the Common Core Regents, because I knew it was going to be hard, we spent so much time preparing for this Common Core Regents. And she took the test, and I said, now I wasn't there to proctor it, I said, Brittany, how did you do? She goes, oh my God, I got destroyed. I said, why? What was so hard about it? She said, every question began with this big, long paragraph. And as soon as I saw the paragraph, she says, I knew I couldn't get it right, and I quit on the question. Kind of like this, big, long paragraph. She said, I just quit, I wouldn't do it. She wound up getting, I think, like a 49 or a 46 on the Common Core Regents. Then she took the integrated algebra Regents. Now, I only spent 2 hours preparing her for the regular integrated algebra Regents. She got a 76. Now, the reason, I said, well, how did you do so much better? She goes, oh, they didn't have big, long paragraphs. They just had a sentence and then a question. So we can't let this big, long paragraph stuff confuse us or bother us. And one of the things I like to do to make it less confusing is cross stuff out when I use it. Okay? All right, so we crossed out the first part. The next part says the result is the same as. What does that mean? Patrick? Equals, good. The result is the same as. Cross that out, slap in your equals. If you multiply the number of dollars by 5 and then subtract 12, how would I do something for that? Multiply by 5 and subtract 12.
It would be 10, but then you would minus
Slow down. I just want the expression for multiply the number by 5 and subtract 12.
5 times 2.
Not 5 times 2, 5 times n, because I don't know what the number is yet. And then minus the 12. So there I go. I multiplied by 5 and then I subtracted 12 from it. All right, now it looks like I have an equation here, but let me just go back and make sure that anything important I've used. Tommy's not sure how many dollars in his bank account. Big deal, whoop-de-darn do. Ask the Grand Deacon of Denaro to tell him, and the Grand Deacon says. Okay, so none of that's important for an equation. This is the only stuff that matters with the equation. This stuff is nice, it's pretty, it's et cetera, it's irrelevant. The only thing left is this. And when you've crossed out everything that you're supposed to use and you ignore everything that's irrelevant, you always come down to a single sentence. And that single sentence is your directions. It's telling you what it wants you to do with the problem. So it says here, how much money does Tommy have in his bank account? All right, so I gotta solve. Always start with the smaller number of n's, minus 2 n's. That 75 is positive, so keep it there. 75 is 3n minus 12. Now what do I do? Darlene, what's the next step?
Subtract 12. I add.
Add 12, because this is a minus 12 here, so I need to do the inverse, or the opposite operation. 87 equals 3n. Divide by 3, die. N is going to equal 29. Did anybody happen to get that? Okay, now that you look back on it, does it seem that hard? No, it doesn't. I don't think it seems that difficult. Okay, so now let's go forward with some more word problems for today's lesson. Try it. Give it a shot. Let's see what you come up with. All on your own. Everybody, what does quotient mean? What was that?
Divide.
I hear one person. Everybody, what's quotient mean?
Divide.
Divide, good, okay. That's a key word in there, right? Okay, so, who wants to read it? Oh, by the way, even before we read this, to do these questions requires the recognition of keywords, vocabulary. Very important to recognize keywords. So once again, who wants to read it? Come on, somebody raise your hand. Oh, so sad. I just got done telling the last period how great you guys were. Leah, that's it, you can lead. Leah the leader, go ahead.
If 3 is subtracted from the quotient of a certain number in 7, the result is 15. Write an equation and find the number.
Okay, talk to me about some key words there. Right, this is a required step. Required means you gotta do it. What are some key words? Patrick? Quotient, beautiful. What else? Darlene?
Subtract.
Subtract, good. Another one, go ahead.
Result is.
Yeah, result is 7. All right, good. And then, of course, it says to write an equation and so on and so forth. So now, we've read the problem once, we've analyzed it. Analyzing means to think about it, all right? We've gone through it, we've thought about it. Now we're gonna put into action. We're gonna take a piece, draw a conclusion. Take a piece, draw a conclusion. So, if 3 is subtracted from the quotient of a certain number and 7, now we just did this subtraction from before. What's the important thing to always remember about the word from there? Goes first, good. So it's subtracted from the quotient of a certain number and 7. So there's my subtraction symbol, and we talked about how quotient means to divide. And the division symbol is just something over something. So here's my quotient symbol. What goes in the top? Yoli?
N,
Good. And what goes in the bottom?
7.
Excellent. So that, what I just wrote on the left of the subtraction sign there, is how I would express the quotient of a number and 7. Now, Schwartz, what's being subtracted?
3.
Good. The result is equals. And what's the result, everybody? 15. I'm gonna add 3 to both sides. Oh, you know what? I went a little quickly, and sometimes I do that. I apologize. First, I used the subtracted from a quotient of a certain number and 7. So that should be crossed out when you use it. The next thing you did was you said, okay, 3 is what's subtracted from. That's crossed out. Then I used the result is 15. That's crossed out. When all of that's crossed out and you reread what's left, it just says write an equation and find the number. So I did write an equation. That's how I used up everything I crossed out. And now I'm solving for the number. Die. N over 7 equals 18. Multiply by 7, because that was divided by 7. N is equal to 126. Okay? Any questions on that? Anything at all? Does it seem that hard? This whole idea of reading once, reread, draw conclusions, cross it out as you go along, and then you're left with the directions is very, very helpful. Try number 2. A little bit of a rush here, so try to go quickly. Okay, Billy measures the toy Camaro in centimeters on a ruler, blah, blah, blah. If he triples the length and adds 9, he gets 42. How long is Billy's toy Camaro? Okay, so, how would I, so many important things here are tripling, adding, and so on. How would I write triples the length? How would I do that? Because I don't know what the length is. Patrick? 3x, good. So, I triple the length, that's done. What else is important that I didn't do yet? Eric? Add the 9, nice. I'm gonna add the 9. Get rid of that. What else is important? Michael?
The
Equals good. And last but not least, what do we get, Yarlene?
42.
42, nice. Now, once we get to this step, this is a standard 2-stepper. From here, I know you got it. You're gonna be fine. It's just getting that step set up. All right, hasta la vista, vaya con Dios, toodaloo, ta-ta. Arrivederci, smile a lot, ciao. Arrivederci, adios amigos y amigas. Cheerio, sayonara, ta-ta, enjoy. Have a good one. Where'd my little cursor go? There it is.